Hello everyone. This is the last lesson of chapter 4 and it covers isosceles and equilateral triangles. So let's get into it. What is an isosceles and an equilateral triangle? Well, these two triangles out of three triangles you may have heard of when you were in middle school or elementary school. Third being scalene, which is basically none of the sides or angles are equal. And these two triangles have special properties to them, which I will get into later in this video because they aren't covered in chapter 4, but they do come up in a later chapter. So if you'd like to get a head start, you can continue watching the video after we do the practices. So, an isosceles triangle is a triangle, obviously, that has two equal sides. And because those two sides are equal, what does it mean for us? It also means that the bottom two angles, called base angles, are equal. Voila. And then an equilateral triangle is similar to an isosceles triangle, except all three sides and three angles are equal, hence the name equilateral. So let's talk about it. Why does it equal 60? Well, our sum of angles in a triangle present to us this. So if we named one angle x, if all angles are equal, then that means the two angles that haven't been named yet are also x. So let's solve for x and see what each angle equals. And we can see here that each angle equals 60. And this is true no matter the size of the triangle, no matter the lengths of the sides. However, in an isosceles triangle, the two base angles aren't going to be set. Rather, they rely on that one top angle you see right there. So let's do some practices. So, off the bat, we see that this triangle is isosceles. So what are we going to do? Let's solve for z. So 2z minus 15 equals 9. Why? Because the two legs here that are marked are equal. So let's solve for z. And you might be wondering, hey, why is that 7 over there? Well, the 7's there just to be there. They're trying to trick you. I won't lie to you. So now we see that this is an equilateral triangle because two of the angles are 60. So that's 120 in total. So if you use the sum of angles in a triangle, what does that equal? The last angle. The last angle also equals 60. So let's solve. 4x minus 2 equals 60. 4x equals 60. 2. My bad, 62. X equals some funky number that we don't want to talk about. It comes out to 15.5. I don't like fractions, but here we are. Anyway, those are just some practice problems, and those are the kind of problems you'll see at this stage. You might have something more complex with a couple like different variables, but overall that's the typical idea you're going to have. And like, just for example, you might have just this indicator and then this angle equals 2x plus like 5 or something, and then this angle equals like 7x minus 4. Don't be freaked out because you don't know any of these like angles. You would just kind of solve because you know the base angles are equal to each other, and that's kind of the only idea you need to have. So that's really the idea, the point of these exercises, and this is kind of the rough idea you will have. And see, that's some of my work that we're not going to talk about. All right. Now let's talk about the different properties that will come up. This comes up in a couple later chapters. I know because I took summer geometry, and also I've learned this a couple times. So I can tell you that this, what I'm about to show you, is very important to later chapters, and you are going to use it once you get to like squares or different types of polygons. And I mean, you can feel free to stop watching if you don't want to get ahead, but this is like my tool or a little bit of explanation that you guys can keep watching to kind of get ahead or have an understanding of this kind of property if you'd like. So let's talk about it. An isosceles triangle has a couple of interesting properties. So if we draw this line down the middle, and we're going to call it an altitude. And you probably may not know what an altitude is, but just in simple terms, an altitude is a height. And it forms a right angle with the base. So that's special. Okay, cool. It forms two right triangles. So you can use it to, say, if you have this angle, or like if you have all those angles, you can use trigonometry, which I will not be getting into, to solve for a specific side, or you can use it to find something else. Or if you know a side, like if you know this side and this side, you can solve for this leg. And then that will in turn kind of get you that leg. And then to find the entire base is the next thing I'm going to get into. Oopsies. How would you do something like that? Well, there's more to this. So that line also drawn down to the base is called a median. And it's exactly what it sounds like. It divides this base into two. So that is two even parts. They are equal to each other. And then finally, this really special line, honestly, it's so talented. It also splits these two angles they're equal basically. They're congruent. These two angles are congruent. and that is called an angle bisector. Yes, it's weird, it's funky, that whatever a bisector is, basically it's kind of in the name. Bi means two. It's like a prefix, and then sector is like a section. So basically, angle, two sections. It splits it into two. So if you see this, if you see something like this, and it doesn't indicate the sides at all or the base angles, there's this property where if you see this triangle and you see that it has two of these things, it can be an altitude and a median, it can be like altitude median, it could be altitude angle bisector, it could be altitude or like median and angle bisector, etc. Or it could be all three. If you see those, you know it's an isosceles. But you only need to see two. You have to see at most two. So those are some of the properties in an isosceles triangle that come up at a later date. And then equilateral triangles, this also applies to it, because if it applies to an isosceles triangle, most likely it will apply to an equilateral triangle as well. So this also comes up in a later chapter, and it's kind of the start to trigonometry. So if you don't know what trigonometry is, it's basically just really wacky and weird, and it's annoying sometimes. But I promise you, this is the best part, and it's the easiest. So this is an equilateral triangle, and that means all angles are 60. So if we draw the line down the middle, we have our right triangle, we have this, and this equals 30. Why? It's because 60 divided by 2 is 30. So that means basically 180 minus 90 is 90, and then 90 minus 30 is 60. So this last angle is 60. And this is something that's called a special right triangle. So that is a special right triangle, and you can use that to find the legs. So this leg, you guys don't have, well, in later dates you'll have to memorize this, but for right now it's just learning for the sake of learning. So we're going to name that x. The relationship between those two sides is 2x, and then this height is x root 3. So that is just some, learning for the sake of learning, some things that you can keep in mind once you keep going. If you have any more questions, just let me know. And that's the end of this video.